Hello guys, today my mom's gonna be teaching you what? Okay, my mom's gonna be teaching you physics, and yeah, you can if you have some doubts in physics and what chapter is this? Okay, and yeah. So without any further ado, let's go. If you guys have any doubts, then comment down below.
Okay, hello my dear children. I'm now going to give you some collective idea about all the chapters in class 12 physics so that it might be going to helpful for your board exam. Okay.
Yep.
So the board exam falls on March 4. So before that, you can have a glance along with me. So especially the last lesson, semiconductors lesson, the diode, PN junction diode is very important. So I'll give you one question. What is that question when a junction diode is reverse biased? Okay, it is reverse biased. Then what is the question? What causes current across the junction? Okay, so your option is given like this. So diffusion of charges, then nature of the material, then drift of charges, then both drift and diffusion of charges. So these are all given. So in your book, so that reverse current, okay, you know that reverse current is mainly due to the drift of charges. Okay, so this is the correct option. Make a note of this. So drift of charges are responsible for the reverse current. It is due to the carriers like holes and free electrons passing through a square centimeter area. Okay, it is given here. Okay, it just passes through square centimeter area, and then that is perpendicular to the direction of flow. That is also very important. The direction of flow is perpendicular. Okay, it is due to the carriers like holes and free electrons passing through a square centimeter area, centimeter square area. Okay, and that is perpendicular to the direction of flow. Do right now. Direction of flow. It is perpendicular. Okay. So this is not clearly given in your book. So you just take a note of this. Okay, this is very important. So when a junction diode is reverse bias, then what happens? What causes current across the junction? So that is the question. It is due to the drift of charges. So the drift of charges means charges, you know, holes and free electrons. It passes through a square centimeter area that is perpendicular to the direction of flow. Okay. Then let me come to another questions. Okay. And then in one thing it is given forward biasing of PN junction offers infinite resistance. Say yes or no. Forward biasing of a PN junction. Keep in your mind, all of you. Forward bias of a PN junction offers infinite resistance. Is it true or not? No, it's false. Right. So forward biasing of PN junction always offers low resistance. Okay. Even in the case of ideal PN junction, resistance offered is zero. Okay, does not offer any resistance during forward bias. This is the correct option. So one more question. Um, so everyone knows that Zener diode is used as a rectifier as well as a regulator, right? It is the voltage regulator. Okay, so how it regulates the voltage? So it can be used as the shunt regulators to regulate the voltage across small circuits. Okay, always Zener diodes operate in reverse bias. That is also you should keep in your mind. Okay, always. Okay, so it is used for regulating the voltage. Then everyone knows that rectification means the process of conversion of AC current to DC current. Okay, that everyone knows. Keep in your mind that point also. Then next one. Okay. Why is there a sudden increase in current in Venezuela? What is the reason? Let me give you the option for this. Okay. So first option is due to the rupture of ionic bonds. Okay. Second point, rupture of covalent bonds. Third point, viscosity, due to viscosity. Fourth point, due to potential difference. Okay, there are four options given. The question is, I repeat, why is there a sudden increase in current in Xenadiol? Okay, the answer will be actually due to the rupture of covalent bonds. Okay, definitely it is due to the rupture of covalent bonds. Covalent bonds only present in the, we know that, right? Always it is connected in reverse bias. That is also keep in your mind. Okay. Then, okay, that's all in this particular diode. Okay. Then we'll leave on to before portion semiconductor diode. Then we'll see intrinsic and extrinsic semiconductors. So intrinsic semiconductors, one question you might have asked in intrinsic. Okay. So the probability of electrons to be found in the conduction band of an intrinsic semiconductor at finite temperature is which of the following? Okay. Keep listening carefully. The probability of electrons to be found in the conduction band of an intrinsic semiconductor at finite temperature is which of the following? So first one is increases exponentially with increase in band gap. Okay. Then second option is decreases exponentially with the increasing band gap. Okay. Then decreases with increasing temperature. Okay. Then fourth one is it is independent of the temperature and the band gap. Okay, increase in temperature. Okay. So fourth one is it is independent of the temperature and the band gap. Independent. Okay. So what is the question I've asked? The probability of electrons to be found in the conduction band of an intrinsic semiconductor, okay, at finite temperature. At finite temperature, it is said to be how? How it will be? The electrons will be at finite temperature. Okay, how the electrons will be? What are the four options I gave? Increases exponentially with band gap increasing, decreases exponentially with band gap increases, then decreases exponentially, decreases with increasing temperature, then the independent of the temperature and the band gap. The answer is at the finite temperature decreases exponentially with the increase of band gap. Okay, that means the probability of jumping an electron from the valence band to the conduction band, this from this to here, okay, so decreases, it definitely decreases when the band gap increases, right? When Eg increases. Okay, so it decreases exponentially with the increasing band gap, definitely. Okay, the other options are not valid. Exactly. Okay, so keep in your mind like this, you might be asked. Then you'll be asked like this in semiconductors, at a room temperature corresponds to which among the following? Okay, at a room temperature. Okay, so what is the first option? They are given first option as the valence band is partially empty, and the conduction band is partially filled up. This is empty, this is partially filled up. Okay, then the option B is pulled up. The valence band is filled and the conduction band is empty. Okay. Then the valence band is filled. Okay. Then the conduction band is empty. Like that. We know that the first option is correct, right? When the semiconductors are at room temperature, the valence band of the semiconductor is partially empty. That means the electrons moves up to the conduction band. From the valence band, it moves up to the conduction band. So it is partially empty and then conduction band is partially filled. So that is the correct one. So like way you'll be asked. Okay. And then you'll be asked like this, a semiconductor is damaged by a strong current because of lack of free electrons. Is it true or false? No, right? It is false. So when a strong current is passed through a semiconductor, then what happens? It may cause many covalent bonds to break up due to heating and thereby to liberate a large number of free electrons. So it is given lack of free electrons, that is false. Okay. At absolute zero, silicon acts as which of the following it is asked? Metal, non-metal, insulator, and capacitor. At absolute temperature, silicon acts as an insulator. Okay. That we know at absolute temperature. Silicon always acts as an insulator. Keep in your mind. Okay, when temperature is increasing only, then it acts like a intrinsic semiconductor. Okay. Okay. At which temperature a pure semiconductor behaves slightly as a conductor? At which temperature? So your option is given as low temperature, and then room temperature, then high temperature, then vacuum. Okay. So the option is high temperature. At high temperature only pure semiconductor behaves slightly as a conductor. That everyone knew, right? Because if at high temperature, the charges gets moved on very easily and its resistance decreases. Okay, so resistivity and conductivity are inversely proportional to each other. Okay. See, one more question is asked in a pure semiconductor. Pure semiconductor means everyone knows intrinsic. Pure means intrinsic semiconductor. Okay. Intrinsic. Pure means it is definitely intrinsic. Okay. So pure semiconductors are intrinsic. The number of electrons in the conduction band will be equal to the number of holes in the valence band. Right. So it could not be doped by any other impurities. Okay. So what is the question asked? In a pure semiconducting material, if current flows due to a breakage of crystal bonds, then what is the semiconductor called? So definitely it is intrinsic. Okay. In a pure semiconducting material, pure semiconductor means it is intrinsic, obviously. Then we'll move on to extrinsic. I'll discuss a few questions, okay, on extrinsic. Let me continue with that. What is an extrinsic? So the extrinsic semiconductor, it is basically doped with trivalent and pentavalent atoms that we know. Okay. So if it is asked like this, on doping germanium metal with a little amount of indium, okay, indium, it's given like that, indium. So indium is trivalent atom, okay. So what does one get? If germanium is doped with indium, indium is trivalent atom. So you must know all the pentavalent and trivalent atoms, okay, which is given in your book. Especially, the option will be intrinsic, B will be insulator, then C N-type, then D P-type. Definitely trivalent atoms produces more number of holes, right? So what is that type? P-type. That we know, right? So a trivalent impurity added to germanium, it produces definitely a P-type. Okay. So P-type semiconductor. Then always trivalent impurities such as what is that? Boron, indium, gallium also you can write. Gallium. Keep writing. Gallium and then aluminum. These are all called acceptor impurity. Okay. Then what else it might be asked in. Okay. Suppose if you're asked like this, a small impurity is added to germanium to get a p-type semiconductor. Identify the impurity. Definitely it will be trivalent. Like that also will be asked. Okay. Um, okay. Then some true or false question also it is asked. Boron when added as an impurity into the silicon produces n-type. How boron produces n-type? It is absolutely false. Okay. Only pentavalent atoms doped with a germanium or silicon, it produces n-type. Okay. These and all you may know. Then, okay. The dominant contribution to current comes from holes in case of which of the following? Okay. Metals, intrinsic, p-type, n-type. So you know that the dominant contribution to current comes from the holes means the majority charge carriers will be holes. So that's p-type. P-type extrinsic. Okay. Um, okay. So that's how you can understand about this. Then how can you classify metals, non-metals, insulators, that is, and then semiconductors. Okay. So the energy band gap. Suppose if the energy band gap is maximum, which of the following? So you can see metals, superconductors, insulators, semiconductors means insulators of the correct answer because the energy band gap is maximum in insulators only. Okay, when compared to all the other categories. So what about the silicon? If the silicon that also we saw silicon at absolute zero, it acts as an insulator. Right. Okay. Then it will be asked like this: a piece of copper. Okay, a piece of copper and another of germanium are cooled from temperature to 77 Kelvin. Room temperature to 77 Kelvin. 283 Kelvin to 77 Kelvin. So what will impact on the resistance of each of them? Resistance they are talking about. I mean the options given are each of these decreases. Each of the resistance decreases. Okay. Then the option B is copper strip. Resistance of copper strip increases and germanium decreases. Then the ulta copper strip decreases and germanium increases. Then each of these increases. Both are increases. These are all the options. What will be your answer? Hmm? See, it is cooling now. Temperature is decreasing from copper to germanium. Okay. What is the correct option now? The correct option will be copper. The resistance of copper increases and the germanium decreases and the germanium increases. Resistance of the germanium increases. Then what happens with the decrease in temperature? Definitely the resistance of copper, which is a metallic conductor. It is a metallic conductor, its resistance automatically decreases. We know that, right? That resistance is directly proportional to the difference in temperature. We know that alpha into delta T. Okay. So if the temperature increases, then the resistance of the copper increases. If the temperature decreases, then the resistance will be decreases. Resistance of the metallic copper first decreases. Okay. Then, whereas the resistance of germanium, it is a semiconductor. Okay. Now, what happens? The resistance of the germanium will increase. So, you must write the explanation like that. The answer is the resistance of copper decreases and germanium will increase. Okay. Absolutely. This is what you must understand. So, suppose if you are given an isotropic isotropic, amorphous, unipotential, among which four options. What are crystalline solids? Crystalline solids are anisotropic solids. Okay, maximum. It shows different physical properties in a different direction. That is anisotropic. Anisotropic means what is anisotropic? Anisotropic is meant to be. It shows different physical properties in a different direction. Okay, is it clear for you? So all crystalline solids are anisotropic. Okay. So suppose what is amorphous solid? Amorphous solid means it is a non-crystalline solid. What is amorphous solid? We can say glass as an example. Okay. It is a non-crystalline solid in which the atoms and molecules are not organized in a definite lattice pattern. Okay. So the remaining are crystal, isotropic or anisotropic. These are all crystalline. Okay. Um, okay. Suppose if you are asked like that, at what temperature a pure semiconductor behaves slightly as a conductor means at high temperature. That we saw already. Okay. So these are all the questions you should keep in your mind. Then we'll move on to nucleus lesson. So what might be asked in this type of questions? These and all you have learned already. Okay. So you might be asked like this. The magnetic moment of a revolving electron around the nucleus varies with the principal quantum number. Okay. That relation, you'll be asked that relation. See, the four options are given. What is the question? The magnetic moment. The magnetic moment is characterized by a letter mu. Of a revolving electron around the nucleus varies with the principal quantum number. As how it varies with the principal quantum number is designated by a letter n. So this is principal quantum number. Okay. So principal quantum number is designated by a letter n, and this is magnetic moment. Okay. So there are four options. How these two are related? That is the question. Okay. Then the second option is mu is equal to 1 by n, and the third option mu is equal to n square, and the fourth option mu is equal to 1 by n square. So what you can write? So how can you explain what is the angular momentum? So the angular momentum, according to Bohr's postulate, the angular momentum of each and every electron in its own orbit is n integral multiple of h by 2 pi. That is nh by 2 pi. Okay. So what is mu now? Mu is equal to, okay, what is mu? Moment. Okay. EL by 2m. That also you have studied, right? What is mu? Mu is equal to EL by 2m. In the previous lessons, yeah, it is connected to the previous lesson. Keep in your mind these two expressions. Okay. Then substitute for L here. In this. So mu is equal to E into NH by 2 pi also there, 2m also there. So 4 pi m. EH by 4 pi m. Okay. So we can say mu is proportional to n. That means here the sign should come like this, but anyways, mu is directly proportional to n. That is the correct option. So A is the correct option. Mu is always directly proportional to n. So take down this. If you want to make a screenshot, you can take a screenshot. So this is the basic relation between the magnetic moment and the principal quantum number of an electron, which is revolving around the nucleus. Okay. Then, so you'll be given some atoms and its atomic number and mass number, like it is given like this: oxygen, then helium, then iron, then uranium, everything it is given. Okay, out of these four, what you have to do? You have to find highest neutron ratio. How can you find the neutron number? What is neutron? Okay. What is the highest neutron ratio? Neutron ratio means the number of protons is to the number of neutrons. How can you find the number of neutrons? The mass number minus atomic number. This is mass number, this is atomic number. So you have to subtract mass number minus atomic number. So what is the mass number of oxygen? 16 minus 8. Okay. So you are asked to find the ratio of the neutron ratio, highest neutron ratio. So oxygen is having 8, right? So 8 proton and 8 neutron. Then similarly, you can find for helium. Helium is very less. Okay, uranium only will be considerable. Uranium, what is the number of proton? 92. 92 is the number of proton. So what is 235 minus 92? 235 minus 92 will be 235 minus 92. So 143, right? So 143 is to 92. So this ratio is very much high, right? Like the way you can explain. Okay. Then what it will be asked? Alpha, beta, gamma rays are deleted in the question. Then we'll see. Suppose if you are asked, if you are given four forces, we know that, right? Electrostatic forces, nuclear forces, gravitational forces, then spring forces. Okay, nuclear, electrostatic, gravitational, and spring force. Okay. You'll be asked which is the non-central force. So in any case, non-central. How can you say non-central? What is non-central? Okay. Non-central means it doesn't it doesn't based on maximum the center of the atom. Okay. That means electrostatic force also based on that. Gravitation also based on that. Spring also based on that. Only the nuclear force. Nuclear force is the non-central force because they are dependent only on the spin of the nucleus. Okay, only the spin of the nucleus. And not on whether the nucleons are protons or neutrons which is revolving around the nucleus. Okay. So it is the non-central force. Okay. Then we'll see the size of the nucleus. So in this, definitely the formula will be given. Okay, most of the nuclear patterns are spherical in structure. The expression is given as R is equal to R naught into the cube root of A. A bar 1 by 2. Where E is the mass number, R naught is the constant. And nuclear radius is measured in fermi-meter, right? This is in fermi-meter, 10 power minus 15 meter. So keep in your mind. And then who measured the size of the nucleus first? Rutherford. Rutherford only measures the size of the nucleus first. Okay. You'll be asked like this. Okay. So you are given 4 options. The first options will be the nucleus with even protons and odd electrons. It is absolutely not possible. Right? Okay. Because if it is an atom, it should contain definitely even number of protons means even number of electrons. That means same number of protons and electrons. So electrons don't come to the nucleus. So definitely it is wrong. Then the nucleus with even number of protons, and then odd number of and then even number of neutrons. Neutrons also even number, protons also even number. Third option is the nucleus with even neutrons and odd protons. Okay. So fourth option is both are odd. Protons and neutrons are odd. See, first option is obviously wrong because electrons does not comes into this category in the nucleus. Okay, the question is for stable nucleus, how the arrangement will be. So the options B will be the correct option. So even number of protons and electrons, sorry, and neutrons. That should be even number of protons and neutrons. Okay, this type of atom are more stable, so this contains more stable nucleus. Okay, so that means they are less radioactive. That is the meaning. If there are even number of protons and even number of neutrons, that is a valid reason they are less radioactive than nucleates containing even number of protons and odd number of neutrons. That is the meaning. Okay. Then, okay, if the internal energy of the nucleus is high, then it is radioactive. It is given. Okay. Reason is, yeah, correct, right? The explanation is what you can do. If the internal energy of nucleus is high, then what will happen? Definitely the atom is unstable, right? The internal energy is very high. It's unstable. So it is radioactive, highly radioactive. Okay. So when there is an excess of internal energy, definitely it can become radioactive. Definitely. Okay. Then a nucleus at rest splits into two nuclear parts. This is one question. A nucleus at rest splits into two nuclear parts having radii in the ratio 1:3. The ratio of their velocities are asked. Okay. Radii is given in the ratio like this, velocities are asked. Two nuclear, a nucleus. A nucleus is split into two nuclear parts. So what type of reaction it is? Fission or fusion? Fission. Right. So you are given what is the option for velocity ratio? It is given. The option 1 is 1:9, 2 is 3:1, 3 is 1:27, 4 is 27:1. Okay, this is what it is given. So the only possibility for us to use the formula, that is R is equal to R naught into A bar 1/3, right? For the first one, you can use first part. Okay, what is first part? R1 is equal to R naught into A1 whole power 1/3. Then second part, R naught into A2 whole power 1/3. Right. If you divide these two, R naught gets cancelled. Then what it will be? A1 whole power 1/3 means you can take like this. R1 by R2 the whole cube is equal to A1 by A2. Right. This cube can be, this 1/3 can be taken as cube to the left side. Is it clear for you? Okay. Then, what is the ratio of the radii? Ratio of the radii is 1:3. So 1:3, the whole cube is the mass number ratio. Their masses. Okay. So 1/9. Sorry, 27. 3 cube is 27. So the ratio of the masses will be 1/27. Okay. Ratio of the masses is 1/27. And then we know that by understanding the principle of conservation of momentum. What is the conservation of momentum? The momentum before split up will be equal to the momentum after split up. That means the momentum of the first part should be equal to the momentum of the second part. Like the way we can take it. So So what is the combination here? V1 by V2 is equal to M2 by M1. What is M2 now? 27. M2 or A2, A1. So whatever it might be, you can use it. Okay. So mass and velocity is the momentum. So by means of the conservation of momentum, law of conservation of momentum, we are using this formula. M1 V1 is equal to M2 V2. From this, we can calculate the ratio of the velocities. V1 by V2 is equal to M2 by M1. So it is 27 over 1. So the ratio of the velocities of the two nuclear path will be 27:1. So take down this or take a screenshot of this. So you are given radii, ratio of the radii, then asked for the velocities. Here in this case, this is the correct option. Option D is correct option. In this case, a nucleus is now splits into two nuclear parts. That is the case. Okay. So likewise, you'll be asked in this size